This is the Financial Algebra Lesson 5-2, Buy or Sell a Car. We're going to first go through some vocabulary words just really quickly, even though you're supposed to have defined them already, just to make sure you understand exactly what they mean. Statistics. A lot of this lesson today will deal with a lot of statistics, so it's important that you understand what statistics are. Statistics are math that deals with the collection, analysis, and interpretation of numerical facts and data. Data is simply a set of numbers, and most of the data that you've ever done before is a measure of central tendency. Measure of central tendencies are single numbers such as your mean, your median, and your mode that are used to represent a typical value for a set of data. Your mean is your arithmetic average, and that is the sum of the numbers in the data set divided by the numbers of the elements in the data set. An outlier is a piece of data that is extremely different from the rest of the data, which means it's either much larger than the majority of the data or it's much smaller than the majority of the data. Your median is your middle number when your data set is ascending or descending order. In other words, if you put it in order from smallest number to largest number or largest number to smallest number, it will be your middle number. In ascending order is from lowest to highest. Descending is from highest to lowest. Data is considered to be skewed when the mean of the data set is not equal to the median. So if you get a different number for your mean than you do for your median, your data is considered to be skewed. A data set is said to be resistant when a value or measure of central tendency does not change easily or significantly due to an extreme value. So in other words, if you have what's considered to be an outlier and it doesn't change your data very much, it's very resistant to that outlier. The range is the set of data that shows dispersion, how spread out the data is. In other words, it's the difference between your highest data value and your lowest data value. Quartiles are three values that divide the distribution into four subsets. That's why they're called quartiles, that each contain 25% of the data. You have your lower quartile, which is considered to be Q sub 1, which is the first quartile, and 25% of the numbers in the data set are at or below Q1. The upper quartile is known as Q3. It is the third quartile, and 75% of the numbers in the data set are at or below Q3. Your interquartile range, which I always refer to as your IQR, is quartile 3 minus quartile 1, and that gives you the range of the middle 50% of your numbers. Your mode is considered to be the most occurring item and is often used with non-numerical values, such as opinions. For example, it's easy to take the mode on what is your favorite ice cream sundae topping, because it's however many people chose chocolate or something of that nature. And then bimodal is a data set that has two modes and only two modes. Data sets can have one mode, multiple modes, or no modes. All right, let's talk for a minute. How does all this data correlate to buying a car? So, how can statistics help you negotiate the sale or purchase of a car? If you're going to purchase a used car, if you know some statistics about used cars before you go to purchase them, you're going to be in a better position to make a better offer for a car and maybe get the price down a little bit. So one of the things that you have to pay attention to when you buy a vehicle is what's more important to you, the mechanical condition of the vehicle or its appearance. Me personally, I don't care if a car looks super great. I want it to run, and I want it to run well, and I want it to run well for a long period of time. I can buy an ugly car. If that ugly car drives on the road for 30 years, I'm a happy camper because it's a reliable vehicle. Other people, it's all about how the car looks, right? It's all dependent upon each person. Okay? However, I do believe that the appearance is a reflection of the mechanical condition of a car. If somebody doesn't take very good care of the appearance of their vehicle, if they don't wash it once in a while, if they've got garbage strewn all over the inside of the car, if they've dinged it up a little bit and never tried to fix it, they have got a broken windshield or something of that nature, it leads me to believe that maybe they haven't done their oil changes on time, or maybe the condition of the engine is about as bad as the condition of the vehicle. So those are things to remember if you're buying especially a used car. Obviously, if you go to a used car dealership, they'll spruce the car up for you because they want you to buy the car, so they're going to make it look as nice as possible. Right? Any person selling you a car personally should do the same thing. Used car prices vary greatly, and a skilled negotiator will have an advantage when buying or selling a used car. So there are things to remember. So let's talk about a few things mathematically that we're going to do in this lesson. Okay, let's take a look at example 1. Jason wants to sell his Ford SUV. He compiles these prices from the internet for cars similar to his. $11,000, $9,900, $12,100, $10,500, and $9,000. What is a reasonable price for Jason to consider for his SUV? Well, the easiest way to do this would literally be to find an average. So, if we're going to find an average for this, I'm going to show you what I would like you to show me in your homework. If you're going to find the average, first thing you're going to do is you're going to add all your numbers up. So 11,000 plus 9,900 plus 12,100 plus 10,500 plus 9,000. And we're going to take all of those and divide them by the number of data points we have in our set. We have 1, 2, 3, 4, 5 data points. All right, so I would like to see this step in your homework, even though I know you can put it on your calculator. Too many of you to put too much on your calculator, and then when you get your answer wrong, I have no idea what you did wrong. Okay, if we add these up, if we take 11,000 and we add 9,900 to that, and 12,100 and 10,500 and 9,000, we should get 52,500. So if I have 52,500 and I divide that by 5, that should give me an average of approximately $10,500. So if Jason wants to sell his vehicle, he probably should keep around the 10,500 range, give or take a few $100s. Right? So that's at least a good place to start for how much he should sell his vehicle for. Okay? It's an average. Let's look at example 1b. Okay. Maxine compiled a list of these car prices: $7,500, $6,500, $5,750, $4,900, $6,250, and $4,200. Find the mean. Remember, mean again is the average. So we're going to do the same thing we just did. We're going to take all our numbers, 7,500 plus 6,500 plus 5,750 plus 4,900 plus 6,250 plus 4,200. Divide that all by 1, 2, 3, 4, 5, 6 of them. All right. So if I take all those numbers, I'm going to add them all up. 7,500 plus 6,500 plus so 7,500 plus 6,500 plus 5,750 plus 4,900 plus 6,250 plus 4,200 is going to be 35,100. Divide that by 6, and you will get 5,850. This should not be hard math for you. This should be stuff that you've done before. Much of what we're going to do today in this lesson is going to be stuff that you've already covered. However, we will be getting into some new material that I'm pretty sure you have not covered yet. So don't fall asleep during this video. Pay attention because it's actually very crucial to your understanding of things. Let's look at example 2. Example 2. Dory is looking for a classic 1967 Firebird. She finds these prices on the internet, and of course they're listed. She computes the mean as $28,171.43. This number doesn't seem to be a good representative of the data. How can she find a better representation? Well, if we look at the data, I'm looking at this data going, it's all pretty good except for this one number here. Okay, $77,000. You're like, wow, why is that one so much more than all the others? Is that a typo? It could potentially be a typo, or it could be a 1967 Firebird that has every bell and whistle and the most elaborate engine you've ever seen, has a custom paint job and a whole bunch of other extra stuff that makes it worth $77,000. So if that's the case, we have an outlier. And when you have an outlier, the best representation is to use the median. Okay, when we have an outlier, you need to use the median. don't leave the outlier out of the data. We just simply use the median. So remember, when you use a median, that means you have to put the data sets in order from smallest to largest or largest to smallest. I normally use smallest to largest, that's just my habit. So if we're going to put all these data pieces in order, the smallest one is 17,500. The next smallest data piece is 18,000. Then we have 19,000. Then we have 21,200. After 21,200, it looks like 22,000. After 22,000, we have 22,500. And last but not least, 77,000. So if we look at this, we have 1, 2, 3, 4, 5, 6, 7 data pieces. Okay, so go from 3 from both ends. 1, 2, 3 from this end. 1, 2, 3 from the back end. We are left with $21,200. So the median is a much better representation, and the median, okay, the median of 21,200 is a much better representation. Okay, so let's look at 2B. 2B says, find the mean and median of the following prices for a used car extended warranty. Okay, and then is the data skewed? The reason we have to find both the mean and the median is that's how you can tell whether or not the data is skewed. Okay, so we're going to simply look at the data, and if I'm going to find both the mean and the median, I'm going to put them in order to begin with. Okay, so I'm just going to start right now by putting them in order. So if I put them in order, 1,200 comes first. Then comes, looks like 1,400. Then we have 1,200, we have 1,400, we have 1,500. And it looks like 1,600. That's down here. Then 1,650. Then 1,850. And last but not least, 2,000. Okay. So to find the mean, that's the first thing we're going to do. To find the mean, I'm simply going to add 1,200 plus 1,400 plus 1,500 plus 1,600 plus 1,650 plus 1,850 plus 2,000. Divide it all by 1, 2, 3, 4, 5, 6, 7 data pieces. Okay, and if I add all of those up, 1,200 plus 1,400 plus 1,500 plus 1,600 plus 1,650 plus 1,850 plus 2,000, I get 11,200. Divide that by 7, and that gives me 1,600 as the mean. The median is going to be my middle number. Since there are 7 data pieces, it's an odd number of data pieces, so it's going to be the number smack in the middle. So the number smack in the middle is going to be this 1,600 right here, because there's 3 on either end. So my median is also $1,600. Since the mean and the median are both the same, so my mean is $1,600. My median is $1,600. So no, the data is not skewed. The data is definitely not skewed. So we found the mean, we found the median. Since the mean and the median were both equal, the data set is not skewed. All right, so what happens if your median is not, you have to find the median and you don't have you have an even number of data points versus an odd number of data points. Okay, so if you have an even number of data points, you're not going to have a number that's directly in the middle. You're going to have several numbers that could be in the middle, actually two. And if that's the case, you have to take the average of the two middle numbers. Okay, you still have to put the data in order from smallest to largest or largest to smallest. So in example 3 here, it says find the median of the following used prices: 6,700, 5,800, 9,100, 8,650, 7,700, and 7,800. We have 6 data pieces. Okay, so it means we're not going to be able to take the middle number, but we do need to put them in order. So if we put them in order, it's 5,800. Okay, then goes 6,700. Then goes 7,700. Then 7,800. Then 8,650. And last but not least, 9,100. So since there's 6 data pieces, go 2 from each side, 2 from the front, 2 from the back, and take the average of your 2 middle numbers. So now we'll take the 7,700 plus the 7,800 and divide it by 2, which you technically should be able to do without actually having to add them up and divide by 2. What's halfway between 7,700 and 7,800? 7,750. Okay, so $7,750 should be the median of this piece of data. Okay, that logically speaking, you should be able to do that one. Okay, let's practice one more of these. So find the median of these prices: 10,200, 9,300, 11,900, 2,999, 17,200, and 9,600. So there's definitely an outlier there. If you look at the data sets, most of them are between 9 and 11,000, except for you have a big giant outlier of 17,000, and you have a really small outlier of 2,999. So we have 2 pieces of data that seem to be outside of the majority of the rest of the data, which means that we have an outlier. So in this case, let's put these in order from smallest to largest: 2,999, then we're going to go 9,300, and then we're going to go 9,600, and then 10,200, 11,900, and then 17,200. Okay, so we have several outliers, the one on each end, a lower outlier and an upper outlier. So that means the median would be a much better representation than the mean. So if I take these 1, 2, 3, 4, 5, 6, so there's 6 data pieces, so take 2 away from the top, 2 away from the bottom, and we're going to take the average of these 2. So if I take 9,600 plus 10,200 and divide that by 2, that would give me 19,800 divided by 2, which is going to be 9,900. So there's finding a mean. We've practiced finding a mean. We've practiced finding a median. We've practiced whether or not your data is skewed. All of that should be review. Okay. Now we're going to talk about a little bit about the range. Okay. The range of data is just what's the difference between the highest and lowest value. A lot of times when I grade a test, I like to look at the range of scores. What was the highest score that was scored? What was the lowest score that was scored? And I like them to be a fairly small range. If it's a fairly small range, that means most people scored around the same test score. If I have a range of 66, I'm a little concerned. That means somebody did either exceptionally well and everybody else did like a C range or D range or F range, or I've got somebody who did exceptionally bad where somebody did exceptionally well. Okay, so let's say you're looking up GPS navigational systems. You want to put a brand new navigational system in your car, maybe your car doesn't have one, and you found the following prices: $295, $345, $199, $225, and $200. To find the range, you're simply going to take the highest price and subtract the lowest price from it. So if we look at this, the highest price is $345, the lowest price is $199, so the range is $146. Okay, so there's $146 of a range for between the lowest priced GPS system and the highest priced GPS system. All right. Let's go back to example 3, where we talked about the used car prices. The used car prices in example 3 had a highest car price of $9,100 and a lowest car price of $5,800. So if we want to find the range there, we're going to take $9,100 and subtract from that $5,800. And that will give us a range of $3,300. All right, now, many times we want to find out more about how numbers are dispersed. When you want to find out how numbers are dispersed, you can often use quartiles. Quartiles are 3 values represented by Q1, Q2, Q3. Okay, that divide the distribution into 4 subsets, each containing 25% of the data. Okay, I'm going to teach you how to find your quartiles and how to find your interquartile range, which is kind of important because these are going to be used in the next couple of lessons that we're going to do. So it's really important that you understand how to find a quartile, how to use the quartiles, and how to find an interquartile range. So it says find the quartiles for the tire pressures of cars at an auto clinic. And the tire pressures range from 15, 17, 21, 25, 31, 32, 32, 32, and 34. Nicely enough, the data is in order. If the data was not in order, you would have to put it in order to find your quartiles. Okay? So the first thing you have to do is quarter 1 is 25% of the data. So we have to find the median. Everything is based upon the median here, not the mean, but the median. Okay? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 data points. Okay, so if we want to find the median, go count 4 from the front and 4 from the back, and you'll find that your median here is 31. Okay, my median is 31. This is important. Okay, Q1, quartile 1, is 25% of the data. That's by definition. Okay. By definition, 25% of your data should fall at or below quartile 1. Okay? So you have to find the median of the numbers below the median. So to find quartile 1, we have to find the median of the numbers below the median of the data set. Okay? So to do that, if we look at that, we have the following numbers. We have 15, 17, 21, and 25. Those are the numbers that are below the median. To find those medians, we have to literally average them together. So we have to average the 2 middle numbers together, which is 17 and 21. Okay, so that would be found by taking 17 plus 21 and dividing it by 2, which is 38. Divided by 2, which is 19. Okay, so Q1 is equal to 19. Extend my page here a little bit. All right, we now need to find Q2. Q2 is always the median. We already found the median. So literally, you almost have to find Q2 before you find Q1, because there's no way to find Q1 without finding the median, which is Q2. So Q2, this is going to be 31, because we already found our median. So Q2 is 31, because it's the median. Q3 is by definition, okay, Q3, all the data has to fall either at 75% of the data has to fall at or below Q3. So to find Q3, we're going to do almost what we did with Q1, except for we're not going to find the median of the numbers below the median. We're going to find the median of the numbers above the median. Okay? So we find this. Okay? It's literally 75% of the data. So you find that by finding the median of the numbers above the median. So we are looking at 32, 32, 32, 34. Okay, so Q3 numbers are 32, 32, 32, 34. Okay, so you take the two numbers, add them together and average them, but they happen to be the same number. So therefore, literally, Q3 has to be 32. Q4 is very easy to find. Okay, quartile 4 is the max value, always. So Q4 is your max value. So on our data set, Q4 happens to be 34. So as you can clearly see, if you mess up the median, you will mess up Q1 and Q3. You should still be able to get Q4 correct. Okay? But it is really hard to get Q1 correct and Q3 correct if you mess up the median, which is Q2. So now you've learned how to find the different quartiles, the 4 quartiles. Okay? It's literally the 3 numbers that break it into the 4 different parts of your data. Okay? So if we look at 5B here, okay, which is based on 5A, 5B says what percent of the numbers in the data set are above Q3? Okay? By definition, Q3 is 75% of the data values. Okay? 75% of the data values fall at or below Q3. So what is above Q3? Well, if 75% of the data values fall at or below Q3, that means 25% of the data values have to be above Q3. Okay. All right, so then we get into example number 6. What is the difference between Q1 and Q3 from the data set in example 5? Okay, well, Q3 from example 5 was 32. Q1 was 19. The difference between the two is 32 minus 19, and that happens to be 13. This value is called your interquartile range. So if you ever have to find your interquartile range, which you will have to find, it's always the difference between Q3 and Q1. So if you mess up Q3 or Q1, you will mess up your IQR. All right, 6B says, find the interquartile range for the data in example 3. Right? Okay, so the data in example 3. Let's go back to example 3. If you look back at your notes, example 3 was the used car prices. And when we put them in order, we add them as 5,800, 6,700, 7,700, 7,800, 8,650, and 9,100. So those were our data points. So first thing we have to find, let's find the median. Okay, I'm going to put down here Q1, Q2, Q3, Q4. First thing I always find is the median, which happens to be Q2. Okay, so I believe we've found the median because that was from example 3. So if you look back at example 3, the median is 7750. So Q2 is 7750. We now need to find Q1. Okay, so we need the median of the numbers that fall under 7750. Well, how many numbers fall under 7750? 3 of them do. 5800 does, 6700 does, 7700 does. The middle number for that is 6700, so Q1 is 6700. Because remember, our Q2 is 7750, which is between 7700 and 7800, which means that 7700 falls below that median. Q3 is finding the median of the numbers that fall above 7750. Well, the numbers that fall above 7750 are 7800, 8650, and 9100. So the middle number there is going to be 8650. And then, of course, Q4 is going to be your highest number, which is 9100. Do you need that? No, I don't need that to find my interquartile range, but it's kind of nice to put it down. Okay, so my IQR is Q3 minus Q1, which in this case, Q3 is 8650, Q1 is 6700. 8650 minus 6700 is 1950. So my IQR is 1950. And yes, I would expect to see this much work in your homework. It's not that much to ask for you to show all your little steps so that we can figure this out. All right, example 7. We are almost done. Not quite, but almost. Okay, example 7. We have example 7 and example 8. It says find the outliers for these tire prices. Okay, now you don't finding an outlier in statistics is different than finding an outlier in mathematics. Okay, because with statistics, to find the outlier, you have to see if something is above or below the IQR. Okay, so the first thing we have to do is we have to find all of our quartiles. Okay, luckily for us, the data is in order, because you can't immediately say, oh, 45 is an outlier and 545 is an outlier. They look like they might be outliers. They may not be outliers, believe it or not. 545 might not be an outlier, or 45 might not be an outlier. Okay, so we need to figure out if there are outliers. So the first thing we have to do is we have to find all our quartiles. So Q1, Q2, Q3, and Q4. Right? I always find Q2 first. It's been my thing since day one. Okay? So if I look at this, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 data sets. So if I go 4 from the front and 4 from the back, 146 is Q2. Okay? So if I want to find Q1, Q1 is the median of the 4 top numbers here, so it's going to be 88 plus 109 divided by 2, which means quartile 1 is going to be 197 divided by 2, which is going to be 98.5. It's all money, so I should put it in dollar sign in there. Q3 is going to be the average of the 2 middle numbers of the 4 highest values. For the 2 middle numbers of the 4 highest values are 202 and 218. 202 plus 218 divided by 2, which is 420 divided by 2, which makes it 210. And of course, quartile 4 is 545. Now, to see if there's an outlier, the first thing we have to find is our IQR. Okay, so that's the very first thing I have to find. I have to find my IQR. My IQR is Q3, which is 210, minus Q1, which is 9850. So if I subtract those two, that is 11150. That's my IQR. To determine if you have a lower outlier, okay, this is really critical to understand how to work it. Okay, a lower outlier is found by taking Q1 minus 1.5 times your IQR. If a number falls under this lower outlier in your data set, then it's considered to be a lower outlier. So my lower outlier is Q1 minus 1.5 times my IQR. That's going to compute the boundary for your lower. Okay, this will give you the boundary for your lower ones. So let's take a look at this. Q1, let's go back up here, is 98.50. So if I take 98.5 and I subtract 1.5 times 111.5, okay, if I do that math, if I take 98.5 and I subtract from that 1.5 times 111.5, 98.5 minus 1.5 times 111.5, I get negative 68.75. So in order for something to consider to be a lower outlier, it has to be below negative 68.75. We have no numbers that are even negative. Okay? So obviously there is no lower outlier. Okay? In our data, we have no lower outlier because no number is below 0, let alone negative 68. Okay? So we have no lower outlier. To find our upper outliers. To find your upper outlier, it's very similar to finding your lower outlier, but instead of using Q1, you're going to use Q3. And instead of subtracting 1.5 times your IQR, you're going to add 1.5 times your IQR. So Q3, if I scroll back up here, Q3 was 210. So I'm going to have 210 plus 1.5 times 111.5. And I'm going to get that value. So if I do that, I have 210 plus 1.5 times 111.5. That gives me 377.25. So any number above 377.25 will be considered to be an upper outlier. If we look at our data, our Q4 is at 545. So we do have an upper outlier. Okay? So that means that 545 is an upper outlier. So even though it did look like perhaps that 45, when we first looked at the data set and we saw all these numbers, it looked like 45 could be a lower outlier and 545 could be an upper outlier. We really only had one outlier in the data set, and that was 545. And that's because the boundary for the upper outlier was 377.25, of which 545 was above that. That's why 545 ends up to be an upper outlier. Okay. So next question asks this. Okay. Oops, I think there was a second part of this. Or maybe not. Okay. Okay, so I'll ask this question. If the store charged $545 for the tire, if the store that charged $545 per tire put the tires on sale for $399, would they still be considered to be an outlier? Well, if they were $399, they would still be above the $377.25. So yes, they would still be an upper outlier. They would still be an upper outlier because they're above that $377.25. All right, last example. Now I'm going to skip this one. We don't need this. Okay, we already did this. So maybe, I don't know why that didn't. There's the 7B. There's the 7B question I had. The store that charged $545 for a tire in example 7 had a sale and lowered the price to $399. Is the new price an upper outlier? Yes. Since $399 is still above $377.25. Okay, so last example. Each year, the 800 seniors in North Shore High School vote for one of the 110 teachers to receive the annual yearbook dedication. The teacher who receives the most votes wins. Can a teacher who receives 9 votes win if every senior votes? And you might say, well, there's no way a teacher can win if they only get 9 votes. Well, let's think about this. There's 110 teachers. Okay. If 880 is split between 110 teachers, okay, we'll take 880 divided by 110, you will get 8 votes. So if one teacher, so if they're split evenly across the board, everybody loves every teacher in this school evenly, so for some reason everybody votes and each teacher gets 8 votes, then nobody wins it. So if one vote changes, yes, one teacher could win if they received 9 votes. Okay. It would be very difficult. And the likelihood that each teacher would get the same amount of votes, very low. Okay. All right. Number 8B says find the mode of the tire pressures for example 5. Okay, let's just talk about that for a second. This is our last question. Remember the tire pressures were 15, 17, 21, 25, 31, 32, 32, 32, and 34. So mode is the number that comes up the most amount of times. And if multiple numbers come up the same amount of times, if all the numbers come up 6 times, there is no mode. But if 2 numbers come up 6 times, and those 2 numbers would be the mode. So here we have the number 32 coming up 3 times, so our mode is 32. So there you go. We just did a lesson on statistical data, of which the only thing that should have been new to most of you was finding the 4 quartiles, doing the interquartile range, and finding your boundary for your upper and lower outliers. Excuse me. Therefore, your homework for today, okay, the homework that you are going to be doing in class today will be to do 5-2, numbers 1 through 13, and key terms 5-3. You cannot work on test corrections today. I'm not going to do that to the sub. That's not fair to them. Therefore, if you want to work on test corrections, if I'm back by lunch, just check in and see if I'm back by lunch. And if I'm back, you can work on them at lunch, or you'll have to wait until Friday. They are going to be due on Monday, so you do have Friday to work on them, and you will have Friday class to work on them, and then they are due on Monday, which is not an A day, so be aware of that. The test corrections will be due on Monday because I don't want to have to be grading test corrections for the rest of my life. So you may start working on your homework now.